Imagine the universe packed into a space smaller than an atom, an origin point of unimaginable heat and density. In a single instant, the Big Bang erupted, not an explosion in space but the explosion of space itself. Time, matter, and the laws of physics all began in that moment. The universe started as a searing, chaotic soup, no stars, no planets, just energy and fundamental particles. Temperatures soared to trillions of degrees, a cosmic furnace beyond comprehension. But how did we get from that inferno to the cool, dark universe we see today? The answer: expansion. From the very beginning, the universe has been stretching in all directions. This expansion is the engine of cosmic evolution, transforming a blazing fireball into a home for galaxies and life. It's not things flying apart in empty space, the very fabric of space itself is stretching. Picture a loaf of raisin bread rising, the raisins, galaxies, move apart as the dough, space, expands. This process set the stage for the universe to cool down. Expansion is the universe's ultimate air conditioner, running for 13.8 billion years. It's the first step in the journey from chaos to the cosmos we know. To see how expansion cools the universe, let's talk about light, specifically photons. In the early universe, photons zipped through the hot, dense soup, each carrying energy tied to its wavelength. Short wavelengths meant high energy, long wavelengths, low energy. As the universe expanded, it stretched not just space but the light within it. Imagine drawing a wave on a rubber band and pulling it. The wave stretches, its energy drops. This is cosmological redshift. As space grows, light waves lengthen and lose energy. The relentless stretching of light cooled the universe second by second, millennium by millennium. The more the universe expanded, the more energy photons lost and the cooler everything became. Without this cooling, the universe would have stayed a chaotic soup forever. The stretching of light was the universe's way of chilling out. It paved the way for structure galaxies and stars and eventually, us. Expansion and redshift are the simple, elegant mechanisms behind cosmic cooling. This process transformed the universe from a furnace to a place where complexity could emerge. The universe's cooling was the key to everything that followed. If the universe began as a fireball, where's all that light now? It's still here, filling every corner of space but stretched by expansion into faint microwaves. This ancient glow is the cosmic microwave background, or CMB, the oldest light in the universe. Think of it as the afterglow of creation, a whisper of the Big Bang's roar. Discovered in the 1960s, the CMB is astonishingly uniform, a baby picture of the universe when it was just a few 100,000 years old. Its temperature? Just 2.7 degrees above absolute zero, a staggering drop from the Big Bang's heat. The CMB is a direct measurement of how much the universe is cooled, but it's not perfectly smooth. Tiny temperature variations are the seeds of all future structure. Slightly denser spots became the birthplaces of galaxies and clusters. The CMB is more than an echo, it's a map of the universe's future. It shows us where the great cosmic cities would one day rise. The universe's cooling is written in this ancient light. For hundreds of thousands of years, the universe was too hot for atoms, just a dense, glowing plasma. Energetic photons blasted apart any electrons trying to join atomic nuclei. Light couldn't travel far, the universe was an opaque fog. But as expansion cooled things down, a critical threshold was reached. About 380,000 years after the Big Bang, temperatures dropped enough for electrons and nuclei to combine, forming the first atoms. This event, called recombination, made the universe transparent. The fog lifted and photons could travel freely. This is the light we see today as the CMB. Looking at the CMB is looking back to the moment the universe became transparent. The formation of atoms was a turning point, allowing gravity to pull matter together. Slightly denser regions began to attract more gas, setting the stage for stars and galaxies. The universe's cooling made atoms and everything else possible. From chaos, order began to emerge. The cosmic dawn had arrived. The universe's expansion and cooling is a cosmic tug-of-war. Gravity, from matter and dark matter, tries to slow expansion. For billions of years, gravity was winning, slowing the universe's growth, but about 5 billion years ago, expansion began to speed up. Something new was at play. Enter dark energy, a mysterious force pushing space apart, accelerating expansion. Today, dark energy dominates, stretching space faster and cooling the universe even more rapidly. In the far future, galaxies will drift so far apart their light will never reach us. The universe will become a cold, lonely place, heading toward the big freeze. Stars will burn out, matter will decay, and temperatures will approach absolute zero. The same expansion that made life possible will lead to a quiet, frigid end. Our existence is a brief, brilliant moment of warmth in an ever-cooling cosmos. The universe's ultimate air conditioner never stops running, and that's the story of how the cosmos keeps its cool.